Today we're going to use the fundamental theorem of algebra. You don't necessarily need to be able to recite this or anything like that. You just need to know how to use it, and you'll be expected in your college algebra class to know how to use this theorem as well. So I'll read through it and then I'll show you an example of how to use it. So if f of x is a polynomial of degree n, where n is greater than 0. So what that means is it has a degree here that's a positive. So this polynomial has degree 5. Then the equation f of x equals 0 has at least one root in the set of complex numbers. When counting all the roots, an nth degree polynomial will have n roots. And we've already talked about that. Because this is a 5th degree polynomial, there should be 5 roots. We call roots and x-intercepts the same. Unless one of our roots is an imaginary number, then it won't necessarily be an intercept. But we're still talking about zeros here. So on this one, and it's different than the previous ones. On the previous ones, we would have something over here where we would say f of something equals 0. So we would at least have a starting point. But on this one, we don't have a starting point. So we're going to need to try to find something that we can start using for division. So the first place that we're going to find our zeros, or our possible zeros. So to find the possible zeros, I'm going to look at the number, the coefficient that is in front of this leading term. So the coefficient that's in front of my leading term is 1. And then I'm going to look at the constant term. The constant term is the one that does not have an x. So I've got to think about the factors of my constant term. Divided by the factors of my leading coefficient. So let's think about, on ours, our possible zeros. So I'm going to have the factors of my constant term, and my constant term on this one is 6. The factors of 6 are 1, positive or negative 2, positive or negative 3, and positive or negative 6. Because 1 times 6 is 6, 2 times 3 is 6. So those are the factors of the constant term. The factors of my leading coefficient are just positive 1 and negative 1. So to find the possible zeros, now not every one of these will work. I'll do 1 divided by 1 and 1 divided by negative 1. Negative 1 divided by 1, negative 1 divided by negative 1. 2 divided by 1, 2 divided by negative 1. So let's do that, and let's make our list of possibles. So positive 1 divided by positive 1 is 1. Positive 1 divided by negative 1 is negative 1. Negative 1 divided by 1 is negative 1, and I already have that, so I don't need to list it again. Negative 1 divided by negative 1 is positive 1. I already have that, so I don't need to list it again. So I've tried these. 2 divided by 1 is 2. 2 divided by negative 1 is negative 2. So I've tried that one. Negative 2 divided by 1 is negative 2. Negative 2 divided by negative 1 is positive 2. So I have all of those. 3 divided by 1 is 3. 3 divided by negative 1 is negative 3. Negative 3 divided by 1 is negative 3. Negative 3 divided by negative 1 is positive 3. 6 divided by 1 is 6. 6 divided by negative 1 is negative 6. And negative 6, we would have already counted those. So these are our list of possible zeros that we can try. So what I could do is go up here and do synthetic division. And I'm going to have a 1, negative 2, 8, negative 13, and 6. And if we were in class and we had a whiteboard here instead of a piece of paper, we would just start by putting a 1 here and guess and check. And maybe 1 gives us a 0 right here, and it truly is a 0, or maybe it doesn't. If it's not, I would just cross it off and try the next one, and so on. But we're going to kind of use a resource to know where we want to start with our guessing. We're actually going to take this equation and put it in our graphing calculator. And again, if you're at home and you don't have a graphing calculator, you can use the TI app that's on the Chromebook. Or you could use Desmos. It's totally up to you. So I'm going to start by typing in this function, x to the 5th minus 2x to the 4th plus 8x squared. Uh-oh, I realize I just messed something up here. I'll fix it. Minus 13x plus 6. What I noticed here is that I had an x to the 5th, x to the 4th. There was no x to the 3rd, so I need a 0 here between the -2 and the 8. I have to have a placeholder for that x to the 3rd. Okay, so I know that I'll have 5 zeros, and I'm going to see if the calculator will tell me the first one. So I'm going to hit graph. And then I'm going to look for the places where this thing crosses the x-axis. So it looks like it's crossing right here at -2. Maybe it comes down and touches right here at 1. I'm going to double check that by hitting second graph and looking at the table. I'm trying to find the places where the y is 0. So yep, -2 was 1, and it looked like 1 is also. So I know that I'm going to try both of those places. So I'm going to start with -2 and do synthetic division. So I'm going to bring down the 1. 1 times -2 is -2. So it'd be -4. 8. 0 plus 8 is 8. 8 times -2 is -16. That'd be -8. -8 times -2 is +16. -13 and 16 is 3. 3 times -2 is -6. And those will cancel and give me a 0. So -2 truly was a 0. So I'm going to circle it. Then I'm going to try the other place I found, 1. So I'm just going to add right back onto my synthetic division. So I know if this was x to the 5th to start with, if I would write the factor right here, this would be x to the 4th. So when I get my answer here, it's going to be x to the 3rd. So I'll bring down 1. 1 times 1 is 1. So it'd be -3. -3, see here, 5. 5. -3, -3. So when I add these, I get 0. So I know that 1 really is a 0. So this was x to the 5th. This was x to the 4th. So this would be x to the 3rd. I'm really not at a good place to start factoring yet. I'd like to get it down to x squared. So I'm going to go back and look at the graph. So if you notice at -2, this goes through. But look what happens at +1. At +1, it just touches. And if you'll remember when we were talking about quadratics, anytime the graph just touched at a place, that means that this solution happened twice. So that means that since it just touches and doesn't go through at 1, 1 happens twice. And that happened in quadratic when we were talking about the vertex. So bring down the 1. And we get a 0 again. So that means -2 is a 0. 1 is a 0 twice. So this was x to the 5th, x to the 4th, x to the 3rd. So now I'm down to x squared minus 2x plus 3. So then I want to try to look and see if this thing will factor, to see if I can get my other zeros. So x, x. And what I notice on this one is it does not factor. So that means that I'm going to have to use quadratic formula. So to find my other two x's, I'm going to do x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So that would be 2 plus or minus the square root of Looks like 4 minus 12, so that's negative 8 over 2. And that would simplify to I here. And 8 would go to 2 square roots of 2. So this would be 2 plus or minus 2I square root 2 over 2. And I noticed that 2 will divide into each of those, so it would be 1 plus or minus I square root 2. So x equals positive I square root 2 or 1 minus I square root 2. So here's 2 zeros. So 1, 2, 3, 4, 5. And since it was x to the 5th, I should have had 5 zeros. You may want to go back and watch this video again. I'm still going to do a couple more examples, but this can be hard to get on your own. So you may want to watch my examples. You may even want to go and watch something else on YouTube. But I'm going to do another example after this one.